All right, so let's hope this works. So we're trying something new. It's kind of a different way to upload, and we'll see how it goes. So we're talking about soil, where soil came from, how do we make it? And if you remember back in 6th grade, environments are made out of both biotic and abiotic components. So biotic, life, living, and abiotic, which is non-living. So right now we're going to talk more about the abiotic parts of soil, because believe it or not, soil is made from both, okay? You both need living and non-living parts, and together that's what makes a really good soil. So like I was saying in our last video, when I had you look at the map and kind of figure out what it is. So below us is that map that was kind of pink and purple and really hard to read. That's the official USGS map. So USGS is United States Geological Survey, and they're the ones that are in charge of doing mapping and all these kind of soil typing things along with the Department of Agriculture. So below us, there was a whole bunch of words: shale, siltstone, dolomite, limestone, and those don't mean anything to you. So this right here, and I got it, is, there we go, limestone. Okay, and it is a chemical rock, that's what we call it, and it was made by being in a shallow sea. And it should be yeah, there we go, very fine grain, and there's only a little bit of sand and a little bit of like silt in here. Mostly it's just that chemical limestone. Okay, now as we go to this guy, this is kind of like a nodule, is what we call it, but this is where you get stuff like dolomite and micrite and all those other kind of ites that we saw on there. And what it is it's super fine. There we go. Almost looks like a geode, and you can see it flaking off just a little bit in there. And again, this is the same kind of thing. It's related to limestone, but it's not quite the same. There's a little bit of chemical difference. There's some size difference. But again, this doesn't have any sand in it. It's all that chemical, all right? If you dip this in acid, it would dissolve and leave behind very little. Okay, like I said, this is made in shallow seas, and that's what a lot of Indiana was made. Okay, so the way we kind of approach these problems is, all right, Mr. Birch said that all of the soil is made from these parts, the bedrock, those limestone, that micrite, that chemical stuff with only a little bit of sand, only a little bit of grit, a little bit of mud. Well, I see tons of sand. Where does that all come from? Okay, when limestone and dolomite kind of break down in the soil, they form is usually like a siltstone. And siltstone is, if you've ever been by a river and gotten that mud and you can feel just a little bit of grit on it, that's silt. Okay, and silt's about the right size where it is in between the properties of sand. So everybody knows what sand is. You can hold sand up and see sand grains. That's the official name for them. And clay. And everybody's played with modeling clay in art class. You can push it between your fingers and it's very smooth, all right? Well, those are sizes. That clay is actually a size. And in between there, so you got sand grains and clay, and in between there's silt, all right? And you need sand and silt and clay to have a good soil. And as you know, we have good soil here in northern Indiana. We have a lot of farms. We have, booming agriculture. So where does this sand come from? Where does this other stuff come from? Because I just said that this is mostly silt and clay. Well, this is granite. Now, this is actually a artifact we found on the farm not too long ago. Well, a couple years ago, but it's a Native American It's either like a hatchet or it was an axe, but I think it's indented enough here where it's, yeah. But this is granite. This came from a volcano, a hot volcano, okay? Granite is mostly quartz, all right? So quartz is just a fancy term of saying glass. Glass is quartz, quartz is glass. It's the same thing. You can refine it and do other stuff to it, but there's a lot of little crystals in here, and it makes it really, really hard, okay? And turns out that sand is quartz. Sand is glass, okay? So this, do we have any volcanoes in northern Indiana? Nope. Was there ever a volcano in northern Indiana? Nope. So where did this come from? No volcanoes. This rock came from a volcano. So a long time ago during the Ice Age, big glaciers pushed ice and everything all across the landscape here. Now this stone, not the hatchet or axe that it was made into, but this stone, this piece of granite, came from northern Canada. And we know that because if we took a slice of this and compared it to the granite up in Canada, it's the same thing. We've looked at it before. There's been tons of studies, and it kind of makes sense because if there's these big chunks of really hard stuff, they're not going to break down. And basically those glaciers are like giant ice bulldozers just pushing a lot of these things. And then when they slowly receded, they melted, and melting it, they would drop down some of that really heavy stuff they were pushing along. Okay? And this is also, we can see evidence of this because northern Indiana is pretty flat. I don't know if you've been other places in the United States, but, you know, towards the east, towards the west, you know, you get through the heartland, and then all of a sudden you get to Nevada, California, Oregon, and there's these huge hills and mountains, and, you know, out east in Tennessee, Georgia, it's these really complex things. And, you know, if you look out in Indiana, it is very flat. I mean, I can see trees that are over 2 miles away, just straight out there. All right. And what happened was, like I said, they're just giant bulldozers. That thing just came through and scraped everything. Then when it came back, it dropped off a lot of these granites. And it also pushed a lot of soil, okay? So when this breaks down, like I said, it's real hard, but it'll break down eventually. You put this in a river, over time, everything wears down. And that's where a lot of our sand came from in northern Indiana. All right, so you're thinking, all right, how this is kind of like how a scientist would think about it. That's a pretty big claim. Giant ice chunks from Canada brought down sand to Indiana. Okay, Mr. Burge. Oh, my thing's doing all kinds of crazy stuff. But let's take another look at it. Let's go. All right, let's look at some hills. So in my theory, okay, that would leave big mounds of sand, big mounds of stuff that the glaciers had flushed out. Well, luckily, I happen to live on a hill. And as we kind of get a little closer, you see it's a little bit higher. But let's check it out here. So, these parts of soil, each size, because you can have different things in there, each size does something different. Sand gives it structure. Okay, they're the big grains. It lets water drain through it. It doesn't let it puddle up because, I don't know if you've ever overwatered a plant, but I have. And it causes it to die because you can't have too much water in plants in their roots. So let's take a look at this. So this is still part of the hill, and you can kind of see there's a little ridge there, but as we look down, it's very, very sandy, okay? And you can actually see the individual sand grains in my hand, all right? Those are those light tan. The rest of the stuff is silt and clay. Now, as we look down in the field, this is all really tan, right? This is all really sandy. And as we go down further and further, it gets darker. So that means that the sand actually piles up in these hills, these little raised features, and it'll actually drain that area. So the next part, we were talking about silt, and wrong side. What's silt? Silt's that medium size. Silt kind of does a couple things. It kind of fills in the cracks, so it's a little smaller. You know, if sand grains are like this, silt would be about like that. And they give it not as much structure as sand, but it kind of is in the middle. It gives it a little bit of structure. And we'll talk in a second about what clay gives it. And clay gives it these minerals, the you know, kind of nuts and bolts plants need to survive. All right. And the silt it carries a lot of kind of exotic stuff. All right. That's where you find a lot of your like phosphates and nitrates, and we'll learn all about these later, but those are the fertilizers. Those are the things plants need to survive. And then as you get smaller and smaller, you get clay, and clay is pretty much concentrated minerals. All right. All it is stuff broken down so fine it's barely holding on to each other, and it lets things slip by. Clays are like a plate, all right? And if you have them piled up on each other, they can kind of move and, you know, do these kind of things. And that's why clay is so slick, okay? Because they're plates and they're sliding on each other, okay? So clays are plates. It's kind of hard to think of a clay being a plate. But imagine it's like super shrunk down paper plates. Now, you can probably put two paper plates on top of each other and then just kind of fold them around while they're still kind of flat. Even if it's bent, it's still pretty flat, you know? It's all right. And those are the three components, and we'll talk about those another time, but those are the abiotic components of soil. So you got structure, you got kind of, you know, your nutrients, and then kind of like a middle ground, all right? And you need all three of those in certain ratios to do really well for soil. So if you go to a desert, you find a ton of sand, of course, okay? As you go into a lot of the mountains, a lot of like Kentucky, Tennessee, down south, you get a lot of clays. And what clays are is the really interesting rocks. The rocks that kind of build mountains when they break down, when they get weathered. Weathered is, it gets broken down by the weather, okay? When they get weathered, they break down into those little plate things. And a lot of the South has a ton of clay. And as you keep going, you get to Florida. And if you haven't been to Florida, Florida's a big beach, you know? It pretty much is one entire beach around the outside. Beaches have sand, okay? And why beaches have sand is because that water moves that sand particles, and it's not small enough to dissolve or become suspended. So a mud puddle is muddy because of the fine parts of soil, okay? Whereas if you just put sand and water and shook it up, all the sand will fall right out. And this is one of the tests we'll do probably Wednesday. But if you get a tube or a bottle or anything that's clear, put some soil in it, and it could be mostly sand, it could be mostly silt, it could be a mixture of everything. But if you put it in there and then shake it up real good to make sure everything gets a ton of energy and stop, the sand will fall out almost immediately, okay? Because it's so big and heavy. And then after a couple seconds, silt will start coming down because it's a little bit heavy, but it's a little bit light. You know, it's kind of in the middle. And a little silt will come down. And then if you wait long enough, the clays will actually fall out, okay? So a lot of times, if you have the three distinct parts, you can actually see lines, okay? There'll be like a tannish brown line, that's for, you know, the sand. And then there's like a brown to kind of light brown. That'll be the silt, and then the clays will be on top. And you can actually see in there kind of the grain size, since they're not kind of clumped together and doing other things and like mixed with soil roots and things like that. But they'll all be part of it. And that's kind of what we find in the Midwest here, because the Midwest has a lot of farms. You know, you think Iowa, Idaho, Missouri, Illinois, Indiana, it's a bunch of farmland. And this mixture of soil, this sand from the glaciers, this silt and clay from the carbonates, the limestone, the micrite, they make this really well-rounded soil. So a lot of the problems with down south, when they have a lot of clay, is water doesn't go through clay very well. Okay, they have plates, and there's so much of these plates popped on one another that water kind of has to do one of these things to get all the way through. All right, and imagine sand being, we can think of it like a sink. Okay, the water we pour in it, if there was nothing there, the water would go straight down into the sink. Sand is kind of like one or two big pots and flipped upside down. And if you pour it on there, if it hits a pot, it's just going to go straight around and right down. And there's only two, so there's not a lot for that water to get caught up on. The next, you can think of like a couple smaller pots or some mugs or something like that. And, you know, it kind of stacked on top of each other. So it might be, you know, a little bit hopping down, but it's pretty straightforward. Go over one, go over the other. And then finally, the clays. Imagine clays is just a bunch of plates stacked up. So it'll go on one plate, and then it'll flow down onto another, and then it'll flow back, and then kind of do one of these little dances down there. And having a lot of clay in your soil means that it doesn't soak down. It doesn't, you know, go away. It just kind of sits there. And this is the problem with a lot of farmland down south, is that it's not well drained, okay? I know I'm throwing a lot of terms at you, but this is just kind of one of those, you know, introductions. Now, again, the sand, if you have really sandy soil, so like my house is on a sand hill, so if I go up there with a bunch of water and just pour it down, it'll be gone in like that, because it's those big grains and it can find its way down really easy. And the happy medium silt, it can find its way down, but it takes a little bit longer. So the fields, the lawns that have a lot of clay in them, you'll see water pool up because it can't get away fast enough. And if you have a lot of sand or a sand hill, you almost never see puddles, okay? Because they'll go and spread out super easy. And, you know, we'll start talking about this a little bit more, but if we have an area that's, you know, really well drained, when it rains, it kind of goes down there, and a lot of that water will go to the local river, and the local river will take it to wherever. Well, what if we build a giant parking lot on there? Well, now none of that water gets down because it's all asphalt or concrete, and water doesn't go through that. And so it'll just flow over like a really flat river. It's called sheet flow. And it'll just flow over and go straight to whatever's in there. So that's why, I don't know if you've ever been around the city when we've had like a really big rainstorm, but there's a lot of flooding. And that's because the rain will hit the roofs, and the roofs will dump that over onto the street, and the streets will get filled up. And a lot of times, you know, that's why we have storm drains, because the rain from the storm go in the storm drains. But a lot of times those will get full, especially if it's a heavy rain, and not enough water can get down there, and the whole road almost acts like a small river and pushes it towards whatever's lowest. So messing with this kind of soil in areas, it's really difficult, and we've messed up quite a few local ecosystems by putting you know, a mall by a swamp. Well, now the swamp, it often floods in these little parking areas. Or, you know, we put it on hills, and all of a sudden, you know, there used to be some vegetation there and they would absorb some of that water, but now it just goes whoosh, and flows right into the local subdivision and floods their houses. So this really delicate balance, as you know, we'll hit on this a little bit more and we'll talk about the different parts a little bit more, but I wanted to kind of get out here and kind of show you that, you know, it's so complicated. Even though there's only 3 parts of soil, at least the abiotic parts, the inorganic, okay, the non-organic, you know, there's only sand, silt, and clay. And in that, you have the entire amount of different soils in the world, which there's about 10 million or something crazy like that. And, you know, in our own little slice here, northern Indiana, it's really unique because, you know, we have this kind of soil that was built up from what was here, that mud, that limestone, that micrite, the dolomite, and it was swamps here for a lot of times. And when the glaciers came in, it deposited a ton of sand, and that really helped our soil kind of develop, become from a swampy, mucky place to, you know, really good farmland, and, you know, places where there are some hills, and a lot of those hills are made out of sand from those depositions, those deposits, okay? Again, don't get freaked out about all the different terms and things. We'll go over all of them, and you can always come back to this video and rewatch them, but I just kind of wanted to take the time to, you know, show you why, you know, our fields are so flat, where you can just look on, you know, that our neighbor's house there is about 1.5 miles away. And then, you know, if you do find, you know, some hills and things, that it's that sand. And also there's my poor shop that got whacked by that tree. But yeah, soil, it's got 3 different parts, all right? 3 parts: sand, silt, clay. At least the inorganic parts. We'll get to the organic parts later. But just remember, it's made out of 3 parts. Sand, big grains, give it structure. Silt, kind of in the middle, does both things. And clay gives it the nutrients, kind of holds it together. It's like the glue, all right? Hopefully this will get on, and I can figure out how to upload it.